Okay, hello everybody. Thank you for joining our webinar today. So today we are going to talk about the latest trends in the cloud computing market, containers, Dockers, and microservices. Containers and Docker have shaken the IT world during the last year and keep on getting a high level of attention. This year started with a strong hype around one more technological notion, microservices architecture. But being a technologically advanced cloud company, we cannot be outside of the orbit of modernity. So to make a more deep dive into the raised questions, we invited two experts, Jay Lyman, research manager in the direction of cloud platform from 451 Research, and Mike Bromy, director of program management, server virtualization in Parallels. Gentlemen, thank you for joining us. And I would like to point that if our attendees have any questions to any of presenters, please do not hesitate and write them to the chat during the presentation. We will answer all the questions at the end of the webinar. So, first of all, let's see what we have at the current market, and Jay can help us with that. Jay covers private cloud platforms, cloud management, and enterprise use cases that involve trends such as cloud computing, the confluence of software development and IT operations known as DevOps, polyglot programming, and open source software. And today, Jay will provide us with some statistics of containers and Docker work. Jay, welcome.
So I'll just go over a little bit of what we're seeing in terms of adoption of containers, which is tied pretty closely with what we're seeing with adoption of clouds. And we'll go over a little bit of, what's driving this, what are the advantages, while the fuss around containers today. Then we'll consider some of the challenges of using containers at scale in production with multi-container distributed applications, and those sorts of challenges that sort of represent the next level for containers, which are still relatively new on the scene in some ways. I'll talk a little bit about that as well. And I'll also go over the sort of outlook and what we see in terms of what portion of spending cloud is going to be and what organizations are thinking about in terms of their spending, increasing, maintaining, or decreasing. But first, let's start off and just sort of define Docker and containers. Docker is a software tool for packaging applications and their dependencies in a virtual container that can run on a variety of infrastructures. And that's sort of important because it addresses the polyglot programming challenge. We also hear about tool sprawl. But basically, there's a lot more going into applications today, whether it's application languages, frameworks, databases, and other components, or more infrastructure polyglot, where we see the need to run applications and workloads on a greater variety of infrastructures. That include bare metal and traditional data centers, and of course, also public, private, and hybrid clouds. Technically, Docker is based on the Linux containers technology in the Linux operating system. Certainly there's more to it technically than that, but it's an important part of what is the technical basis for Docker. And it sort of continues the evolution of containerization for deploying applications, services, and workloads, particularly on cloud infrastructure, where, again, that portability, that flexibility, and also the lightweight nature of this is important. There's a lot of hype around Docker and containers. We hear talk about it being the next generation virtualization, a replacement for VMs. And while I think that there is some of that hype gets into hyperbole and superlatives, we actually see, Docker and containers playing a role alongside virtual machines, and that's just the nature of enterprise IT. What's existing, what's there, needs sort of to be accounted for, needs to be considered. We don't think that Docker is necessarily going to replace all enterprise virtual machines anytime very soon. If it does replace 5% of them, that's still pretty significant. And that sort of gets to the last point here. There is some substance to the sizzle And we can see this as an analyst firm based on the inquiries that we get. When we talk about trends such as DevOps, which is sort of faster, more agile application release process and IT operations, or platform as a service. Those trends involve speaking mainly with vendors and investors. And then it wasn't until 1-2 years later that we started speaking with large enterprise end users interested in those trends, those topics. With Docker, it's a contrast. We see the end users right there alongside the vendors and the investors. So it does indicate perhaps a faster trajectory. Now, I'm just going to sort of lay the ground for some of the research. I'm going to go over some of our survey work from the Voice of the Enterprise. And this is sort of a network of enterprise IT professionals that we tap for surveys and for interviews to come up with our research and really provide the quantitative research to go along with a lot of the qualitative research that we do in terms of speaking with investors and vendors and end users, as I said. So when we look at cloud computing adoption, we can see where there's some opportunity or some place for Docker and containers. When you look at the adoption of the different layers, we increasingly see a presence for containers in almost all of these. SaaS, certainly. Both we see Docker and container services delivered as services. So those are SaaS for Docker, and then we also see SaaS with Docker, SaaS that's built on Docker, and it's a part of some of those new microservices sort of architectures and methodologies that are, I think, trying to sort of accommodate some of the same challenges as Polyglot and take advantage of some of the scalability, elasticity of cloud computing. We also see Docker, of course, in private clouds, whether on-premises or hosted. OpenStack is a platform that I follow pretty closely, and we certainly see Docker and containers playing a significant role there. We see Docker on the public cloud, and we've seen a lot of involvement from public cloud providers, Amazon, Google, Microsoft, all of which have been pretty aggressive in their support of and in some cases even partnering with Docker and Company. So we see a lot of interesting things going on. One example is Kubernetes, the Docker management technology from Google and some other partners, but pretty broad support for this. And of course, platform as a service, where containers were kind of born. Docker before it was .cloud, a PaaS provider, and kind of pivoted, but it still very much lives in the PaaS space, centered on application release, continuous delivery, and some of those parts of PaaS. We can also see, again, more opportunity and sort of places for Docker. I think this is one part of why it's been, why it's had so much traction and attention and interest. Perhaps somewhat surprisingly, when we look at cloud applications, more than half, 55%, involve production applications. So we're less likely to see Docker and containers there, although that's changing, and we do see some production applications depending on, and the other thing is, I guess, to remember here is that, Docker is sort of a newer version of containerization, and we have had containerization for quite some time, for years in the enterprise. And so there are production applications, running on containers today. Nevertheless, most of the newer genre of containers is still sort of in the test and dev and evaluation categories. But nevertheless, we see that's almost 30% or 1/3 of the application, deployments and focuses for organizations in the cloud. We also see when we consider new applications that didn't exist before cloud. This, again, is significant, 34%, and also significant for containers. Since this is one place we know Docker and containers technology are playing a role, and a pretty prominent one. And we would also expect Docker and containers to be a part of modernizing applications and moving them to hosted software or SaaS, another 35% there. And in terms of modernizing existing applications, probably not as likely to see Docker in a role there. So now I'll just like to go over a few of the the drivers and advantages, and then we can talk about some of the challenges and hurdles. But I get asked a lot, why is there so much focus on this? Why all the fuss about containers today? Well, it represents a modern, lightweight application container technology for cloud. And when we hear about this emerging, the next point is this serving as a standard amid a lack of standards in enterprise automation and operations and development. Docker and containers is very much sort of oriented toward the developers and the lines of business that are putting that to work. It's more of a novelty, and that gets into some of the challenge for the central IT or the IT operations team. But nevertheless, there's a lot of, I think, confusion and need for support in the enterprise in terms of supporting all of these different tools, polyglot programming, and tools for all, and different infrastructures. And organizations, the whole idea of polyglot is that it's the best tool for the job. Sometimes an application language or framework offers benefits on the back end in terms of scalability or performance. Sometimes it might have front-end benefits in terms of UI or presentation. And so, we also have big data and NoSQL databases and technologies such as Hadoop playing a significant role. So organizations want to be able to provide their developers and their teams the ability to use all of these different tools, some of which are oddly named. But at the same time, that becomes very difficult for a large enterprise with hundreds or thousands of divisions and perhaps hundreds of steps in their application release processes. So they need some help sort of managing that. And again, I think Docker sort of and containers are serving as a standard amid sort of a lack of standards in how you do this in the enterprise. And so organizations are, eager to sort of normalize, standardize, and make these types of deployments repeatable, and Docker sort of fits the bill for that. We also see the vendor and developer support. I should mention, the projects around Docker and containers are also pretty interesting. But, we see not only sort of new agile startups, but we see sort of the mega vendors involved in backing. I mentioned some of the public cloud providers, and there's interesting involvement from VMware, Microsoft. It's certainly something I think that's prompting the vendor community to sort of step up their game and respond. In terms of advantages, I think the reason that it's emerging as a standard for developing and deploying applications in the cloud era is because of the flexibility, the portability for applications, workloads, and services. And that's critical as we see organizations trying to fully leverage cloud computing resources. So not only are they tapping into cloud, but they're tapping into it efficiently, or more efficiently, I should say, and leveraging public clouds where they make sense and where they're comfortable doing so, but also private clouds and hybrid clouds when they want to have control of data security, compliance issues, which are real issues for large enterprises. But again, Docker's sort of fitting the bill of that portability for the cloud era. I've talked about the coverage of polyglot, both at the application and the infrastructure layers. And this last one is kind of key, even though sort of DevOps is all about collaboration and bringing together developers, IT operations teams, and others, including security, database administrators. Docker and containers provide a nice delineation of jobs, and not silos, but some separation so we know who does what. And basically, if an issue is inside of the container, that's something for developers to deal with. If the issue is occurring outside of the container, then that's something for IT operations. So it provides some of that sort of a framework for organizations to go about a DevOps without getting too mired in those teams and not knowing who does what and where the handoff actually is. In terms of challenges, we see a lot of vendor focus on management and orchestration of containers at scale, and I think that remains an ongoing sort of evolving part of this. We see a lot of web applications, but as we sort of move into more enterprise applications, there's a need for greater ease of managing large numbers of containers, multi-container applications, distributed applications, and the more complex applications that you see in enterprise. The other thing is sort of a lack of parity with today's enterprise VMs. And I do hear some assumptions sometimes, that Docker has equivalent, security, multi-tenant security as today's enterprise VMs, which have had, a decade to evolve. So there is a lack of parity there. And, again, there's a lot of developers and organizations working on addressing some of these gaps and, achieving that parity. But we're still a ways off from that. And so, again, the multi-container, multi-tenant, complex application support can still be a challenge for sure. Security, I think, and when we look at these sort of hurdles, inhibitors, they're right along the lines of what we see in terms of the hurdles for cloud computing in general. So security, including data management and data services, is a challenge. I think the complexity of Docker and containers and using them with existing infrastructure. And this is always, I think, a challenge as we see DevOps and automation and agile IT operations spread, beyond Web 2.0 and technology startups, and even beyond some of the early adopter enterprises, such as, financial services, insurance, or telecom, getting more into mainstream enterprise and into, a number of other verticals. They're really facing the problem of mixing and interfacing this new way, more agile, faster iteration, automated IT operations with the old way of doing things, which is very different sort of command and control, stability oriented IT operations. So those two things have to, including sort of the process, the technology, and the people. So this is sort of a DevOps challenge that Docker and containers, I think, share, in that you just have to deal with the existing infrastructure and the legacy investment that an organization has. And then we also see sort of the shadow IT challenge with Docker and containers. And this is sort of a case where developers and lines of business are just using technologies in sort of a one-off manner. And so it's not normalized or standardized or sanctioned by central IT. And frankly, it's a little bit more nuanced than that. I call it shadowy IT because I think in today's age, developers understand that they need to bring in, developers and lines of business get that they need to bring in central IT, and security even is becoming, I think, a priority for these teams. And then at the same time, on the other side of this, central IT operations teams fully understand that they are under the pressure to provide infrastructure, to be more responsive, to basically be faster. And they're competing with some of these shadowy IT resources, such as Amazon and other public cloud, SaaS applications, open source software, and premium applications as well. So we'll just sort of go into the outlook for Docker and containers, and it's sort of tied with new applications here. And I think the point of this is, while other infrastructure, including bare metal servers and traditional data centers, are also relevant for Docker and containers, most of that we're seeing, on the cloud. And then we can see here that, when it comes to new applications and IT projects, the cloud is definitely, the preferred route. So, this, I guess, bottom line, this bodes well for Docker and containers. And then when we look at actual spending, IT budgets seem to be increasing, and even including some of the larger ones. And so, given that the outlook for cloud spending being solid, I think that the outlook for container spending looks fine. And we think more cloud spending will certainly mean more container spending and investment. So I'm going to be here to answer questions as we go through, listen to some of our other speakers. But now I'm going to turn it over to our other folks. Thank you.
Jay, thank you very much for good overview. So as we can see, containers technologies are of a high interest nowadays, and they keep developing. So containers, from again, like why it took so big attention from the market, like because again, like it provides lightweight packaging instead like full VM, and you can move from single large monolithic architecture to dozens of microservices, and you can put different part of your application into containers, and it simplifies migration between different clouds, and yeah, it simplifies maintenance of this different part of applications. And containers inside Jelastic, so we are using them from 2011, at the beginning actually. Jelastic is a pioneer platform as a service which started to use containers for production. And it's production-ready solutions with advanced containers orchestration and live migration and high availability for microservices. So we will cover this area deeper during our webinar. And I would like to give, I would like to ask Mike Bromy to provide some kind of overview about technology which is used inside Jelastic. So Mike, please go ahead and feel free to share some kind of information about development roadmap and latest achievements that you got with containers. As I know, live migration like Creo was committed into vanilla Linux kernel. So it's very good point, and because for Dockers, it becomes a very powerful feature for Docker's containers. So can you share us something interesting about your plans and the latest achievements?
Yeah, of course. Thank you, Ruslan. So what are parallel containers? So first of all, they were developed long ago, started more than 10 years ago to mitigate the problem with virtual machines. So at the beginning, you had only virtual machines, which basically need to emulate whole system with CPU, with a memory controller, and so on, and then you can install operating system inside. This was not very fast and efficient, and nowadays it's a bit better due to hardware virtualization and so on. But due to this, Parallels, or formerly SW, decided to develop a new technology called Parallels containers. So basically, we started from scratch because no container technology was available at this time, and it just isolates different operating systems, so almost only Linux distributions, of course, under one kernel, and isolate each environment from each other. So basically, our containers allow you to run a Linux operating system under a shared kernel, so you can deploy Debian-based Linux distributions, Fedora, CentOS, and so on. Yeah, all of them are fully isolated and have guaranteed resources and guaranteed limits. So what it makes it pretty much different from LXC nowadays or from other technologies is that, first of all, we have a fully isolated container. Second, we support limits, not only for network, also for CPU. So you can partition your CPU on a server to define some limit in megahertz or in a relative value and assign it to a particular container, the same for virtual CPUs. And we also offer limits for memory, guarantees for memory. It's possible to overcommit resources inside the container. So when the system has 3 resources and one container needs more than guaranteed, it's possible to allow such container to burst such resource. And also, of course, we offer I/O limits in terms of bandwidth and in terms of IOPS, which is pretty much unique feature of parallel containers. And what we recently achieved is we pushed our technology support upstream into OpenStack. So from next OpenStack release on, it's possible to deploy parallel containers using stock OpenStack distribution. So it's pretty much completely integrated solution now. What we are working on right now is, especially in terms of Docker, right now with Docker it's possible to orchestrate and package applications inside the container, but they are not very well isolated from each other. So we can start developing it beside our containers so that they stay as a neighbor container to our container technology, but it's not the ideal solution from our perspective. So what we do right now is we develop nested container support. It allows you to run a Docker container or multiple Docker containers inside our container technology. So when you need good isolation for a couple of applications, you just spawn a couple of containers called parallel containers and run Docker inside. And another benefit of this approach is whenever you have a lot of containers already deployed and running, like Jelastic, for example, based on parallel containers, it's quite easy to deploy Docker containers inside. So they will allow you to run multiple Docker instances inside a perfectly isolated and limited parallel container. So basically, it allows you to limit and isolate Docker containers.
Okay, Mike, thank you very much. As we can see, parallel-led containers on a totally new level. So, and I believe your work with Docker, implementation will provide benefits for the whole IT industry. So,
yes.
and again, like we realized the power of parallel containers at the beginning, and this is one of the key bricks in our solution. And what is Jelastic? A little bit high-level overview. So Jelastic, it's a mix of two solutions, platform as a service and infrastructure as a service, and it's container-based solution from the beginning. So Jelastic provides ability to write innovative applications and deploy legacy applications. So you can migrate legacy applications into Jelastic without any code change, and you can scale it at least vertically. So, or you can, you will have ability to redesign your topology and to scale it horizontally.
It seems to me we have some problems with Ruslan's connection. So I think that we are going to just present this presentation, and I will provide the rights to Dmitry Lazarenko, and I hope soon Ruslan will come back and can proceed. Thank you.
Thanks, Fiona. So, as Ruslan said before, Jelastic is a cloud platform that combines both platform as a service and infrastructure as a service solution in a single box. And Jelastic originally is based on containers, and we use parallel containers from 2011. And as a platform as a service solution, we used Parallels Virtuoso containers for Linux, and currently we use Parallels Cloud Server, which is an evolution of Parallels containers for Linux. And as a platform as a service, we are targeted on Java, .NET, PHP, Ruby, Python, Node.js. And recently, with help of Parallels team, we have added Docker containers. We have brought Docker containers in Jelastic, so it's possible to use Dockers. And from infrastructure as a service perspective, we provide IaaS for Linux and for Windows based on containers from Parallels for Linux and for Windows. And one of the main benefits that containers provide for end users is that automatic vertical scaling and really high density. So the density of containers comparing to VMs, it's about twice or 3 times better than the density of VMs like VM or VMware. From technologies perspective, we support Java, and originally we have started as a platform as a service for Java, and we support both Java Standard Edition and Enterprise Edition via JBoss, Glassfish, Tomcat, TomEE, Jetty, Whitefly, and others application service. All the major Java versions are supported starting from 6 up to 8, and our users is also able to use PHP or Ruby or Python, Node.js applications which are running inside Linux containers. And we have we have just released the latest version of Jelastic, which provides ability to run ASP.NET and .NET applications, also desktop .NET applications right inside Jelastic. And this version also contains feature which allows to run multiple Docker containers and integration with Docker registry hub. So that's about middleware and language platforms perspective. And as a platform as a service, we also provide first-class support of SQL and NoSQL databases. So PostgreSQL, MySQL, MariaDB, and actually Microsoft SQL 2012 are available, and they can be scaled both vertical, up and down, and most of the databases can be scaled horizontally with using master slave or master replication. And from NoSQL database perspective, we do support MongoDB, Cassandra, Redis, Neo4j is one of the most popular graph databases right now. And we also provide support of caching service like memcached. So vast of middleware, a lot of automation and expertise on proper configuring of different lifecycle actions. So all of them are provided by Jelastic as platform as a service solution. Ruslan.
Yes, I'm here. Sorry, guys, I am at the conference, so next is not really stable here. So languages, again, like we provide certified containers for runtimes, and you can upload any middleware, software, or applications inside the Dockers. And you will use the power of parallel containers together with advanced Docker application packaging format. So multi-containers environments, it's one of the most important part of our product. So we provide ability to complex topologies with different middleware stacks for different runtimes. As you can see, you can create load balancing layer, application service layer, like different kind of databases. And if it does not meet your requirements, you can create empty VPS node, like, and upload any kind of specific applications, like legacy or like console applications. So, but for standard runtimes, again, we provide certified containers and we provide advanced information for them. multi-containers configuration. And customers are able to configure groups of containers to define scaling limits for vertical scaling and for horizontal scaling. And you can attach public IP addresses for your containers or enable high availability for specific application servers by one click. So it's a very advanced, powerful panel. So about Dockers, I believe you saw this picture in the past, and Jelastic uses Dockers inside. So Jelastic is a smart orchestrator, and our value is an orchestration. And we are using Virtuoso containers together with Docker application templates. So Docker support and Jelastic dashboard. You can see again like advanced panel. You can choose different Docker templates from public registry or from private registry, and you can build different kind of topologies like with load balancing and with application servers, databases, and extra services. And we release Docker supports this week. We started to push our update, the release on productions on different countries. So if you would like to try how it works, please follow our announcement, and you will see which production was updated recently. High-level overview of implementation Docker inside Jelastic. So as you can see, we added shared storage. It's like gray in the middle of the picture. We pull Docker templates to our shared storage. It speeds up actually deployment significantly. And after that, we distribute Docker containers, Docker templates across the hardware nodes, across the cluster. And you can see zoom of our containers. So we're using 3 solutions for containers. At the bottom level, we are using, again, like parallel Virtuoso containers because it provides advanced network isolation and security, advanced security. It provides live migration, which is very important for, in our case, when, for example, hosting service provider or enterprise company would like to do some kind of maintenance of hardware, so they can migrate all containers from one hardware node to another hardware node without downtime. Or you can migrate containers from one region to another region, offline or online migration. So and it provides advanced like limits for I/O usage, for memory, for CPU. So we can set very granular limits for containers. In the middle, we are using Dockers for application packaging templating. So you can pull different application templates or middleware stacks templates. You can connect the public hub registry or private hub registry, and it simplifies deployed workflow. And with Jelastic, so Jelastic provides additional automation for containers. So if we know what exactly inside container, as we, so for example, as I mentioned before, we are using certified containers. So we can add additional automation. For example, vertical scaling for Java applications. It's not easy actually. So we spent about like 1-2 years to build a good solution for automatic vertical scaling for Java and for PHP and for the rest, the runtimes. We provide automation for clustering of complex applications. So also you can deploy your application across multiple containers by one click or by one call, API call. And also you can build your custom scripts on cloud events. We will cover later this point. And you can link containers on multiple hardware nodes. So microservices. Microservices are gaining momentum. So microservices, in short, it means like decomposition. So there are patterns for microservices, building applications as a suite of services. So application can be scaled and distributed across containers across the cluster. And each part can be configured and monitored independently. So you don't need to rebuild and redeploy the whole application if you want to do to add some changes. And so services, microservices can be written on different programming languages. And the most important thing, these microservices can be managed by different teams. So in the past, enterprises and and other companies, like small, medium companies, so they used very often monolithic application architecture. So it gives it provides a lot of complexity. So you can see it provides complex QA process. So you need to redeploy the whole application if you want to change one component inside. So it's not really flexible. So with microservices, if you use decomposition, it provides much better flexibility, and it speeds up the development process significantly. So a couple examples from real customers. It's publishing company. So they, for example, they're using one environment with multiple containers for application server, and they're using another environment with database for database actually, which runs more than 30,000 organizations. So, and they are able to manage different part of their service with different environments. So they can clone environments, they can redeploy application, and they can swap domains between application servers if they upload a new version. So, and another example, like music encyclopedia company. As you can see, they're using two microservices like web applications and batch application. Batch microservice is used for importing new data once per day. It has dynamic load, so very often it scales up to 110 cloudlets, but in average, in the most cases, it uses about 0 cloudlets. So they use power of our vertical scaling. And web nodes can be scaled up to 30 cloudlets, but they never reach more than 20 cloudlets. Oops, another another example. It's more complex example. So research and publishing software company. They're using several microservices. Apache cluster for application server and for application, and set of NFS servers built on VDS nodes and PDF microservice and Postgres database. So they use decomposition for their complex applications, for their complex environment, and they have flexibility when they redeploy new version or of application or new version of database schema. Gambling company, similar stories, so they use different 3 environments for their application. So let's go and cover some the most advanced features of Jelastic. As you can see, one of the main difference of our solution, vertical scaling, and thank you to Parallels containers because they provide core feature for this vertical scaling, and it saves a lot of resources for companies. And in public cloud, it saves money for end customers. In private cloud, you can put much more applications on the same cluster. So it provides significant density for companies. Horizontal scaling. So you can scale containers horizontally. So you can define triggers for different for CPU and memory at this moment, and I/O and number of requests are coming soon. So you can define again like triggers when additional node should be added to your topology. So we are using smart distribution of containers. For example, when you create an environment with multiple containers, we distribute them across the cluster, so we know where is the best place for each new container. And moreover, we are using anti-affinity rules. We distribute containers from the same layer. For example, let's say application servers layer. We distribute them across different hardware nodes. So it provides availability in case of hardware fails. Live migration, as I mentioned, one of the most important features in our solution for big organizations. You can migrate containers from one hardware node to another hardware node without downtime. And we are working on regions feature, availability zones, and customers will be able to migrate containers from one zone to another zone, from one region to another region without downtime. So actually you don't need, if you want to move your application from a dev environment to test environment, you don't need actually to commit to hub registry and pull it again on test environment. You can just migrate from dev to test without extra efforts. And the same story if you want to migrate from test to productions. So you don't need to connect your hub registry to productions because it brings additional security issues. So you can use live migration or offline migration for this, like for such kind of workloads. Flexibility for development. We don't care. We provide access to SSH access to containers. So again, like we don't care if people want to change something inside. We don't provide any limitations. And also we provide open APIs, so you can build complex workflows with Jelastic. So also Jelastic provides features for large teams when you can share environment from one dev guy to another dev guy. For example, one guy can manage like resources, and another guy can just deploy applications inside, or just to do some kind of maintenance on the application. So, and we provide out-of-the-box solutions. If you install Jelastic on private, on public cloud, in addition, we install like Parallels Cloud Server for high availability of hardware, and we install additional monitoring solution to monitor the whole cluster. We provide additional built-in business analysis tools. And we provide 24/7 support. Marketplace, another good feature of Jelastic. So you can use predefined set of templates, about 250 applications, or you can add your own template. So it simplifies provisioning of complex environments. So for example, in organization, you can pre-configure specific applications for your dev guys or for your ops guys, and so you can restrict them to use some technologies, and you can simplify the way to provision complex environments. High-level overview. So On the bottom level, so we can Jelastic can be installed on bare metal hardware, and we recommend to do it. But in some cases, our customers are using Jelastic on top of public infrastructure as a service. For example, for hybrid cloud scenarios. So you can install Jelastic on any public cloud infrastructure, like Amazon, like Google, like Azure, like Rackspace, like SoftLayer. And we are using containers, virtuoso containers or Docker. So if you use virtuoso containers, it provides advanced features. But in the future, you will be able to use standard Dockers if you don't care about specific features. And Jelastic Smart Orchestrator. So this is our actually value here. And we provide three panels, like Dev Dashboard, Ops Panel, and Marketplace. Business opportunities. So you can use Jelastic for mostly for two cases: to provide public services to end customers, to small medium businesses, to startups, IT, consulting service companies, web shops, and so on. Or you can use Jelastic also, actually in public cloud, you can use Jelastic for virtual private cloud for large organizations. Or Jelastic can be used by enterprise for private cloud and for hybrid cloud as well. Target customers, like enterprises, developers, DevOps, and government organizations. So for our partners, we provide additional materials like sales support, marketing materials, technical trainings, and demo clusters for big customers. And Jelastic is proven technology, so it's used around the world, about 25 countries, as a public cloud service. And we started to move to private cloud direction. We have private customers, so they're happy. Actually, they migrated from other kind of platform as a services, and today they're happy with our solution. So that's all on my presentation. Thank you very much. Do we have any questions?
Yes, Ruslan, we have some questions from our attendees. Yes, we have some. So first of all, I would like to start with the questions to Jay. The first question is, why is there all of this renewed attention and buzz around containers when the technology has been around for years?
Yes, yes. Thank you, Tatiana. Well, it's a good question. It's a common question. And the bottom line answer is that, I think Docker renewed interest in this. Docker was written in 2013 and really gained some momentum last year into 2014. It's modern, it's lightweight, and I think it adds the user interface, and that has helped, revive a little bit more interest in this. And I think that's sort of the renewed interest. And even though containers have been around for a while, Docker benefits from being modern and having been written at kind of the right time.
Okay. Thank you. Thank you, Jay. There is one more question to you. I would like to complete with them, and then we will proceed to the questions to Ruslan. How much of the interest and use of containers centers on test and dev work versus production applications?
Yeah, this is sort of another common question, and I think the short answer is most of this is in test and dev. Again, there are exceptions, given that we have had containerization like what Parallels provides for some time. So some of those applications and workloads are in production, but the majority of this is test and dev with Docker and the newer container technology. And I guess the other thing to mention there is that, one, the sort of gaps that exist are getting addressed. The right end user itches are getting scratched. And the other thing to mention is that, in today's environment, with today's timeline, anything that's in test and dev will soon rapidly be moving to production. and the timeline between test and dev and production is much more fluid and much more rapid today. So, I think it's mostly in test and dev, but we certainly see growing use in production, and that's sort of building on, some existing production use of containers that's been around thanks to technologies like Parallels.
Okay, great. Maybe Mike has something to add to this question, because it seems to me this question is totally connected with Parallels, because Parallels containers are the first one who made the step ahead, and maybe you can comment on this as well.
Well, actually,
Like production-ready containers, I will say.
Yeah, production-ready.
And actually, almost, I would say, almost 90 or more % of our containers are used for production-ready applications, because they are used for using virtualized or serving virtualized infrastructure to end users. So basically, they are not used for other purposes, just for integrators or companies like Jelastic, which use technology the heavy benefits, and for the wide range of usage scenarios, but mainly they were fully developed for service providers to build offerings for virtual private servers and sell them to end users. Over the years, we just extended it by a couple of additional features to make it more attractive to companies like Jelastic, which use them now as the base of their platform.
Okay, great.
But
great.
most of our containers really are used in production for production-ready applications.
Yeah, thank you, Mike. And here are some questions. It seems to me these questions are more to Ruslan. So the first one is, what is Jelastic's answer to customers who are going do-it-yourself way and implement their flavor of PaaS themselves with Docker or CoreOS containers with their own orchestrations and so on? I think there are a lot of customers, developers who do not buy into the PaaS platform, Jelastic presence, for various reasons. Can we, as a service provider, use Jelastic as EAS container platform and let customers implement their platforms on top? This is the question from the attendee.
Yes, so actually, yes, it's possible because like Jelastic provides API. So we have API which is how to say, like API for infrastructure as a service and API for platform as a service. If you need only infrastructure as a service layer, so there is no problem to use it. So I believe it's possible to implement any additional custom logic on top of Jelastic, and to write any like advanced UI interface.
Okay, hope you answered the question of the user. So the next one is, from which Jelastic version are Docker containers supported?
From which Jelastic version? Okay, from 3.1. We recently built RTM ready to manufacture like build, and it will be moved to production from this week. Actually, tomorrow, I believe one of our partners will be updated to the next version. So during the next month, all productions will be updated to new version.
Okay, thank you. How is service discovery implemented or implementable in Jelastic?
At this moment, it's possible to publish your services to marketplace, our marketplace, but it requires additional conversation with service providers. So if you are using private cloud, there is no like issue, and if you want to publish your service on one of our public hosting cloud service providers, so you need to talk to our service provider, so and they can publish your service in our marketplace. And in the future, we are going to implement built-in billing, so end customers will be able to resell, to sell their solutions through marketplaces of our partners around the world.
Okay, one more question from the attendees. Currently, Jelastic already supports the most popular languages in Dockers. What do you plan next? What technology is in your nearest roadmap?
Okay, thank you for the question. Good question. So there are two main focus on the near future. In the near future. So first of all, cloud scripting. We are going to introduce new way to do DevOps management of multiply containers. So because today we see a big complexity with current implementation, with current workflows. People are using like Chef, Puppet, and similar tools to manage infrastructure and to build continuous deployment and continuous integration workflows. But these tools were designed for infrastructure as a service. And for platform as a service actually implements the big part of functionality of these tools. So, and we are going to introduce new technology which we call like cloud scripting. So, end customers will be able to build custom scripts, custom hooks on cloud events. It simplifies drastically the workflow. So this is one important thing, and we got very good feedback from creators of Java language, of PHP language, from our advisors actually. So, and second thing, we are going to release the regions, like ability to build complex deployment workflows across different regions for hybrid cloud. Because hybrid cloud becomes a very hot topic. We hear almost from each new private cloud customer about hybrid cloud scenarios. So customers, they want to keep private data or big data inside their company, but they want to use public clouds to extend like resources for some spikes or to sell their microservices or their services on public cloud marketplaces. So these two main things, like cloud scripting and hybrid cloud, will be in our focus for the next half of year.
Okay, thank you for the answer. And we have one more question. So please, if you have any other questions, guys, please just send me them and I will provide them to Ruslan. So one more question is, talking about Docker, you mentioned the ability to bind custom scripts on cloud events. Do you provide some integrated tool for such binding? Can you provide
this
some
is what
details?
exactly I recently mentioned. It's about cloud scripting. So, you know, like today, like platform as a services, honestly, they provide like toy scaling. So you force it to use some specific patterns to build your applications for scaling. And it doesn't work for many enterprise applications. And you cannot tweak some rules of scaling. So in our solution, it's different. So we would like to provide the full flexibility. And for example, you can add some hooks when resource usage is about some limits, defined limits by a customer. For example, if load RAM usage is about 80%, our platform can add one more node, and customer can bind custom script before this node will be added and after this node added. So it provides extreme flexibility for end customers, so they can do additional actions after scaling or before scaling. And so in the same, so similar approach can be used when you deploy application. So for example, you deploy some kind of newer version of application, you can trigger additional actions. To call additional APIs, for example. And similar story when you clone environment and so on. So we have a wide range of cloud events. And integrated tools, yes, we are going to provide like Cloud IDE for this cloud scripting, because like everything will be in the cloud, and you don't need to use like extra additional tools to write cloud scripting. But of course, we will provide plugins for the most popular IDEs as well. So it will be pretty flexible choice. So I hope I answered the question.
Okay, thank you. Thank you, Ruslan. It seems to me these are all questions that we have.
Diana?
So thank you for your answers.
Yeah, definitely. Thank you guys that you joined our webinar today. Thank you, Jay, and thank you, Mike. So if you wish to get more details about our Docker implementation, please follow our blog post. We are going to release a pretty detailed description of our implementation and our vision of the future with Dockers and Rockets and Parallels and hybrid clouds. So thank you again for your time, and I wish you everybody a nice day or nice evening.